So what are the disadvantages, or we can say the comparison between the sequential lobbing and the conical scaling is that the angle accuracy can be no better than the size of antenna beam width. There is a variation in the echo signal on pulse by pulse, okay, with the help of the basic changes that the signal level is also going to be changed, which ultimately reduce the accuracy of radar. Third, the antenna gain is less than the peak gain in the beam axis direction. So it reduces the maximum range that it is going to be measured. So over here, accuracy, range is going to be changed. One accuracy is going to be changed with the help of variation in the echo strength, and second, it is going to be changed based on the size of the antenna. So accuracy depends on what is the size of my antenna as well as what is the strength of my echo signal, right? And the disadvantage of the conical scale is antenna scanning rate is going to be limited by a mechanical. So it may cause a mechanical error. Second, it is sensitive to the target modulation. And third, if there is a mechanical vibration due to rotating field, it may cause the error in the azimuth and the elevation angle rotation of antenna. Okay, so these are the disadvantages of sequential loading, and this is for conical scaling. Alright. Now third one is the simultaneous lobbing. Now what does it mean? With a single pulse, angular coordinates which can be obtained, so we are able to determine the maximum unambiguous range, but it is limited by PI, that is a pulse replication frequency. So this simultaneous lobbing, which includes the monopulse, that means we are only going to transmit a single pulse, okay, which is free of mechanical vibration, and the error due to the amplitude fluctuation of target echoes that are going to be reduced with the help of simultaneous lobbing. Okay, so this is the error of conical scaling, this is the error of sequential lobbing. Both these errors are going to be nullified with the help of simultaneous lobbing. So what is monopulse? So it is defined as the one in which the information concerning about the angular location of target is going to be obtained by the comparison of the signal received in two or more forms. Okay. So we are going to transmit the many pulses which are employed to increase the accuracy. So you can see that the accuracy of this monopulse is not going to be affected by the amplitude fluctuation of target echo, right? So the most popular monopulse is the amplitude comparison monopulse, right? So let us focus on amplitude comparison monopulse. As its name suggests, it compares the amplitude of received echo signal, okay, simultaneously received in the multiple squinted waves, determining the angle, right? So this required squinted beams are going to be generated by two slightly displaced field on the parabolic reflector. So while this difference pattern is going to be operated, we are able to generate for the sum pattern. Sum pattern is used for the ranging and the difference pattern is used for the angle measurement. Alright? So the signal received will be in the two form as I have told you, sum and the difference pattern. So these two patterns are going to be amplified with the help of amplifier and they are going to be combined at the phase sensitive detector. Why? Because we need to produce the error signal. That error signal is totally dependent on the angle. Okay? So on which angle we need to rotate the antenna. So this sum signal, as I have told you, is used to get the range information, and the subtraction signal, or we can say the out of splitter signal, is going to get the information about the angle. Right? Now the phase sensitive detector. This system contains a phase sensitive detector that compares two signals of the same frequency. Right? It is a non-linear device. So this output indicates the direction of angle which is relative to the both side. This is the axis perpendicular to the antenna. So more this phase comparison is there, we are able to extract the magnitude of error signal, which going to be determined by the comparison of amplitude signal, right? So the sum and difference signal. With the help of azimuth and the elevation both side over here, you are able to find out that there are 4 circles W, X, Y and Z. There are total 5 intersections between WX, XZ, ZY, WY, and in between the intersection of all this circle. Right? So for that we require the 4 horn monopulse for feeding. Okay, to feed the antenna. Okay. So it generates 2 signals. First one is the summation signal, which is used for range information, and second one is for the angle information. Right? This is subtraction signal. This is the addition signal. W plus X plus Y plus Z. This is subtraction signal. Okay. But the subtraction signal is separate for the azimuth as well as for the elevation. Right? As there is an amplitude comparison monopulse is there. Over here, the phase comparison monopulse also exists, in which the 2 antenna beams are going to use to obtain the angle measurement in one body. So how we are going to do is the 2 beam which is look in the same direction as it is in the earlier case, but over here they look at slightly in different direction. Okay. So what is the limitation of this phase comparison? Over here the effect of this grating lobes will be present. Why? Because there is a wide separation between the antenna. Right? Based on that, it may cause the ambiguities in the angle measurement. So to overcome this problem, we may require the portion of this parabolic reflector to slice off to achieve this. Okay, to overcome these two error because of the angle measurement. Alright. Now amplitude and the phase comparison monopulse. For that, as I have told you, it generates sum and a different signal. The sum signal is only a single signal, and the different signal, one is for azimuth, other one is for the elevation angle. Okay. We are able to extract the range information from the sum signal and angle information from the different signal. Alright. So it is going to be detected after the amplitude detection. Alright. So the angular error signal is going to be obtained by comparing the echo amplitude, which actuates the servo mechanism to position the antenna. Right. The angle of arrival is going to be determined by comparing the phase difference between the signal of two separate antenna. But the antenna of the phase comparison are not offset. Alright. So over here we have studied in chapter number 5 that how this tracking is going to be done. So in tracking, the first information is range, azimuth angle, elevation angle, and the Doppler shift frequency is going to be obtained. What are the different methods of tracking? It is like conical scaling, sequential lobbing, and the third which we have done, that is monopulse. Monopulse have two types, amplitude comparison and the phase comparison. Right? We have studied the comparison between sequential lobbing and the conical scaling. What are the disadvantages of that? And we have seen which one is better and how to overcome that disadvantage. That we have used the monopulse tracking. Monopulse tracking have two types. What are the two types? The two types are amplitude comparison and the phase comparison. In amplitude comparison, two signals are going to be generated. First one is sum signal, second one is a different signal, right? Sum signal is used for range information and a different signal is used for the phase signal, okay? Or we can say the angle information, alright? Apart from that, we have seen the comparison between the amplitude comparison monopulse and the phase comparison monopulse, right? Which one is better? That we have discussed in chapter number 5. So over here, chapter number 5 is finished. But still, if you have any question, you can ask me at any time on my below email ID. So the next session we are going to start chapter number 6. Till then, thank you for your attention.